Hello, my name is Helen, and today I am going to be presenting my two ways of solving this problem. This problem says that every time these two wheels are spun, two numbers are selected by the pointers. What is the probability that the sum of the two selected numbers is even? So I'm just gonna call this spinner 1 here, and this spinner 2. For spinner 1, the probability of getting a number for like spinner 1 and spinner 2 is proportional to the area of the total area of the circle. So we see that the spinner 1 is divided into 4 equal parts. So that means that for spinning one number, the probability is 1/4. And for spinner 2, it's divided into 3 equal parts, so the probability of spinning one number is 1/3. Now, let's use even-odd analysis to find how the sum of two numbers can be even. So odd plus odd is even. Odd plus even is odd. Even plus even equals to even. Even plus odd equals to odd. Okay, so we see there's case 1, which is odd plus odd, and case 2 is even plus even. So before we get into method 1, which we're going to use some probability in, we're going to need to know some background info about probability. So here we have the probability of event A and B is equal to the probability of getting event A times the probability of getting event B. And the probability of getting event A or B equals to the probability of A plus the probability of B. So with those, and these two rules will only apply if if event A is not dependent on event B, or if event B isn't dependent on event A. And here the two events are the spinners, and the spinners don't affect each other in any way. So that means that these two equations, so we can use these two equations. So now if we use case 1, which is odd plus odd, we see there are 2 odd numbers, the spinner 1 out of 4 numbers in total, so the probability is 1/2. And we see that we have 2 odd numbers in spinner 2 out of 3 numbers. That means that the probability is 2/3. And we see here that we need 2 odd numbers. So odd number, so this is the probability of event A, and we need the probability of event B, and we have to get an even number. So we have the probability of event A and B, so we see that the sign is multiplication. When we multiply, we get 1/3. Case 2, we have the even numbers. There are 2 even numbers out of 4 numbers in total in spinner 1, so the probability is 1/2. And there's 1 even number out of 3 numbers in spinner 2, so that's the probability is 1/3. Same thing with case 1, it's probability of event A and B, so we have multiplication. We get 1/6. Now we have 2 cases. Let's just figure out the sign. And so both of these cases will result in an even number. So we don't need both of them at the same time. We only need one of them at a time. So that is the probability of events A or B, so we use addition. So that means that 1/3 plus 1/6 equals to 1/2. That's the probability of the sum being even. Now let's move on to method 2, which we'll be using counting in. So probability equals to, in this case, the sum to be even over total number of outcomes. Total number of outcomes. Okay. So we're going to find the sum is even for now. And using this even odd analysis, we have that these two. So odd plus odd is even. We see that there are 2 odd numbers in spinner 1 and 2 odd numbers in spinner 2. So each odd number can be added to each odd number here 1 time each. And for 5, let's say, it can be added to 9 and 7. 3 can also be added to 9 and 7, which means that the number of ways for odd plus odd is 2 times 2, which is 4. Now we have even plus even. There are 2 even numbers here and 1 even number here, which means that for this case, the number is 2 times 1, which we all know is 2. Now, when we add this together, we get 6, which is the number of outcomes when the sum is even. Now we have to find the total number of outcomes, which means, so each number here in spinner 1 can be added 1 time to each number in spinner 2. So there are 3 numbers in spinner 2 and 4 numbers in spinner 1, so that is 4 times 3 equals 12. When we plug it back into this equation, we see that it's 6 over 12, which is 1/2, which is what the answer is. Now note that method 2 is not scalable. If I say 20,000 counters or like 20 spinners, there's not really a good, it's going to be hard to be counting every single way. So these are my 2 methods of solving this problem. Thank you for watching.